Okay. Today, we are going to talk about how energy is transferred using a collision. Okay, turn to your neighbor. Do you remember what a collision is? If you're not sure, it is on the chart for us. What's a collision? You guys hear each other? Okay. 5, 4, 3, 2, 1, 0. Give me a thumbs up if you remember what a collision is. Do you want to tell us what a collision is?
When something or some things crash together.
Yeah, when things collide, when they crash into each other. Let's move this out of the way. All right, I don't have an ability to move the slides though. This is interesting. And I'll get it. I got it. Okay, no problem. Thank you. All right, our learning target. We will use FAIR tests to investigate the effects of the speed of a collision when there's a moving ball and a motionless ball. Should be exciting. Okay, so in your own words, what are we learning today? Let me show you what I wrote. Just click to the right. You're going to make observations and learn more about what happens when two objects collide. Okay, turn to your partner and just talk quietly in that nice whisper voice. What are we learning today? Review it in your own words. Go.
Learning when two objects collide. When learning the difference
Two things collide.
and a person. 8.
5, 4, 3, 2, 1. Thank you. Now, I'm wondering, why do we need to learn this? Why do we need to learn what happens when things collide? How many of you have ever collided with something? Thumbs up or hands up. Yeah. Well, we need to better understand what happens when we have a collision and energy is transferred from one thing to another. It can cause a lot of, it can cause some injury, it can hurt your car. Also, there's a lot of effects that are interesting to watch, and we're going to talk about that today. All right, what have we got? Okay, we reviewed our vocabulary. Thank you so much for kind of taking that brain break with me and reviewing vocabulary. Let's keep going. Oh, all right. How many of you have ever seen this game? Just give me a thumbs up if you've ever seen this game. It's called what?
Pool.
It is. It's called Pool. I hear someone over here saying they've heard it. I've played it before? Nice. Okay. So let me give you just a little background. You can put your hand down. This stick is called the pool cue. It's the only way that you can touch the balls. You use the cue, and the only ball you can hit is the white ball. It is called the cue ball. That white ball is then used to hit the colored balls, and you want to hit them in these holes. There are 6, and those are called the pockets. Do you want to share something about pool really quick?
You're not supposed to hit the cue ball in the holes.
That is true. That is really true. So you might lose points or even lose the game if the white ball goes in the pockets. You only want the colored balls to go in. There's one more thing about sharing. Oh, I've got 2.
And also, you win whenever all of your colored balls is hole and stripe. Whenever all of your balls are inside the hole, but you have to finish it off. You can hit them at any time, anywhere with the cue ball, but except the black
Oh,
balls,
yes.
which
Yep.
if you hit in the ball whenever you're not done with all the other ones, you lose the game.
Okay.
That's the finishing one.
Nice. All right. Because we're short on time, what he's saying too is there is a game where sometimes your stripes are solids and you hit your ball in, but if you hit the 8 ball in too soon, then you lose the game, and you wouldn't want to do that. Okay, well, people who play pool have to know a lot about collisions. They have to know a lot about collisions because their job is to use collisions to help them win. When we watch this, okay, if you are, so you all are at tables. We have A, B, C, D, E, F, right? So if you're an odd number, which would be 1 and 3, I want you to watch for soft and hard shots. See how they use soft shots and hard shots. If you are an even number, I want you to watch and see what happens when the two balls collide. So when they hit, do they like both go different directions? Does one stop and one move forward? What happens when the two balls collide? We're only going to watch about a half a minute, and we might even have to watch it twice just so you can really think about what's happening. And we're going to record these ideas. What did you observe? We're going to record them right here. Okay, are you ready?
Get this extremely high-tech $3,000 drone for a fraction of the price.
Yeah. Okay. Oh, you know what?
Dr.
We need
Dave
to
here
go.
with the 25
Would you
best
pause
pool
for a
shots
second?
of all time.
We need to go to 1328, I think. Okay. About right there. Yeah, that's exactly what we want. Okay, here we go. Here we go.
In this great match, Nick manages an amazing comeback, being down 9 games to 2 in a race to 11, starting with this safety escape from Mike Siegel. Nick has a look at the 1, but can't get a shot at the 2 down table. This is where the magical comeback begins, with an amazing sequence of shots.
He wants to hit just before the side. Little right hand English, left hand English.
Look here.
Well, he might be trying to just make a thin hit.
Oh, see, that's the problem with that shot.
Oh, so close.
He's kicked 2 balls in this rack. This rack alone, he's kicked 2 balls in when he had to, when his life was on the line.
The 6 doesn't go in the corner. You got a lag this in.
Oh, well. Okay, we'll watch one last shot here.
He's trying to slow it down with a little hand.
Just soft spin that one in. Boy, that was a nice shot, wasn't it?
It was a great shot.
Another slow spin in.
Nick run
Okay.
these last 3 balls. That made
Thank you. I saw soft shots and hard shots. I saw a lot of collisions. Okay, so now pair up with your 1 and 2 or 3 and 4 and talk about what you noticed. Be ready to share. Go. What did you notice? What were you watching for?
He was doing it a bit hard.
What did you notice?
I noticed that there were some hard hits and almost went in, but he hit at the right angle and he hit most of them.
Nice. 5, 4, 3, 2, 1. Fantastic. If you give me your eyes for a minute. Number 2s. Number 2s, you're going to share. I'm going to try to run around and also record your observations. So here we go.
Sometimes they go the same way, and sometimes they go different ways.
After a collision? Okay. Sometimes they go the same way. Other times they go a different direction. And when you say sometimes they, that's the pool balls, right? Okay, number 2. Thank you so much. Number 2. Where did I put the spoon? I don't want to lose it. Thank you for waiting your turn. Here we go.
What I saw was that a lot of the times, or what happened every single time was there would be an unbalanced force and it would set the other ball into motion.
Give me a thumbs up if you heard it say, unbalanced force set the ball in motion. Every time? An unbalanced, unbalanced force set the ball in motion. I think I hear him saying it was stationary and then the ball went into motion. Is there another number 2 who wants to share? Number 2. Oh, she's got her writing. Nice.
He hit the white ball and then it hit the colored ball and then it knocked another one in the pocket.
Okay. He hit the white ball. It hit another ball, which then hit another ball and put it in the pocket. I think there's some energy transfer there I'm thinking about. He hit white ball, then it hit another ball, which hit another ball. It went in the pocket. Okay. Briefly, we want to get some ideas about why do you think that happened. I'm going to listen for Finley, but I also was hoping she can tell us a why. We're making a hunch. We're making a guess based on what we know about forces. Why do you think these things are happening? A change of direction, setting balls in motion, hitting 3 balls in a row. Why is it happening? Turn and talk. Go.
The stick and then that ball rolls and it can go into
5, 4, 3, 2, 1. Finley, why do you think these things are happening? I get to hold it. Sorry.
Because of the energy coming from the pool stick hitting the white ball. Then the white ball goes and hits another ball, which transfers energy to that ball, and then that ball can go into a pocket.
Could you please give her the sign? Give her the wow
I was gonna
sign.
say the same thing.
Oh my gosh, how many of you were going to say something really similar?
I was
Nice.
gonna say like the stick the stick transferred energy to the ball and the ball transferred energy to the other balls.
Perfect. So the pool cue transferred energy to the cue ball, which transferred energy to the colored ball. Okay, that is awesome. Where did the energy come from in the first place? Where did the energy come from in the first place?
The ideas that keep hitting like the ball, the stick.
The person who hit the ball with the stick. Okay, so this is interesting to me. Are you ready? Because one of the things that scientists know is that energy doesn't disappear, it's transferred. Energy doesn't disappear, it's transferred from one object to another. So let me go back. We had the ball, colored ball, was hit by the white ball, was hit by the pool stick, cue, was moved by the man, how did he get his energy? Well, maybe from breakfast that morning. And how did his food grow? Do you see how the energy just moved from the food to the man to the pool cue to the ball to the second ball? Their energy is just changing form. Okay, give me a thumbs up if that makes a little sense anyway. Energy is transferring forms. It doesn't go away. It just moves to different forms. Here's what we're going to do. We're going to explore these ideas. I'm going to give you a setup for each table group. And you guys are actually going to be a group, and you're going to be a group, because 5 just seems so big. Let me show you what your setup looks like. This is going to take a little responsibility. How many of you are feeling like it will be hard, but you can do this responsibly, because it will be fun to explore energy? Thumbs up if you think, yep, I can do this. I'm seeing a few thumbs up. Okay, nice. Oh, thank you. All right, so here is what your setup looks like. Here's what your setup looks like. And if your back is to me, would you just turn your body so you can really see it? Thank you. Can I set it right here? Okay, so you have this lid. The lid just serves the purpose so that your ping pong balls are not rolling all across the room or falling off your table. And we have 2 ping pong balls. Are ping pong balls light or heavy by your experience? Light. They are light. They are light. My curiosity says, I wonder what would change if I'm changed to heavier or larger ping pong tower balls. But that is a good question for another test. Here we go. One of these is going to be stationary, and it's going to sit pretty much in the middle, wherever you can get it to sit. That one wants to kind of roll. There we go. So I'll set it more stationary as I can. All right. You might have to go to the floor so it will stay. Let's pretend that one's going to stay. And I'm going to use the other one as the ball that's in motion. I'm going to use a finger. I'm just going to call it a flick. I'm going to use a flick, and I'm going to see what happens. Now, oh yeah, I see somebody going like that. That's going to shoot our ping pong ball possibly outside of the box, which would be strike 1. All right, we're going to keep it in the box, and we're going to use a gentle flick, although we want to see, right? We want to see if a soft flick or a, what would you call it, hard flick is going to give us more energy and what it will do. All right, we're going to try it with 1 stationary and 1 moving ball, and person 1 and person 2 gets to try it first. Yes. Person 1, listen up. Whoa, listen up. Person 1, you're going to do it 5 times. I practiced, and I'm going to tell you this right now. Sometimes I missed. You don't get a do-over. You just get 5 turns, okay? Your turn will come back around, but everyone's going to get a turn. 5 flicks. And the rest of the people are watchers. Can you hang on just a minute, please? Can I have your attention? There you go. Okay, so if you're flicking, my friend, these 3 are watchers. You're going to watch what happens with the other balls and how quickly they move. Then you'll do it how many times? 5. Then person 2 gets to do it 5 times. We'll observe and we'll share. Do you know what is happening? And then when I give us a signal, right, we're going to stop. Even if you haven't had 5 turns, I might have to stop us early. I'm hoping you get all 5 of your turns. Person 1 and person 2. When you each get 5 turns, then you stop and you talk about it. Let's give it a shot. All right. So you guys might want to stand up and get a little closer. It's perfectly good to stand up and get a little closer and see if you can tell what is happening. All right, here we go. You get to flick. You get to sit. Give it a shot. Uh-oh. Maybe you might have to go to the floor without the lid.
3,
Ooh, I like that one.
4.
You can see what's happening.
I can barely see the thing.
It's okay for you to stand up and get a little closer.
Force.
5.
Okay. Talk about what you saw. What happened when a moving ball hit a stationary ball?
It was keep like moving around, and it's like going back and forth and like different.
Yeah. So
They mostly went in corners.
Yes.
if once, try it right now. Let's just take a look and see what happens. Nope, this one to that one, William. Oh, try it again. Oh, that was a light move.
That's all you're supposed to have. All you
Whoops. You have a little time to let the third person try it if they haven't already. 5 flicks.
Everyone has done 5 flicks besides Peyton. He did 6.
Oh no. So what do you think happened? What did you notice?
I got set in motion.
Your flick set the ball in motion?
Made a cue.
Yes, you did. What did you notice when the balls hit one another?
I don't know, but I made a cue. Somehow.
Yeah, I get what you're saying. Right. Did you have a chance to try it?
Yeah.
When you hit one, were you able to hit the other ball?
I have not tested the cue yet.
I know we're not going to be able to test the cue, unfortunately. All right, the last person should have 4 flicks if they have it. Be ready to describe what's something you observe, right? There's no right or wrong answer. If you observed it, be ready to share.
What you guys observe?
All right, I'm drawing a spoon.
1.
Oh, yeah, but you know, well, that's okay. I drew the spoon. 5, 4, 3, 2, 1, 0. I'll know you're ready because your hands are off the ping pong balls and you're just looking this way. That's super respectful. You guys have been fantastic. Fantastic job today. Number 1s. Let me hear from a little...
You.
All right, Madison clearly wants to share. Madison, what did you observe, my friend?
I observed when you give the ball a little force, it can hit the other ball into the corner.
Okay, when you give the ball a force, I love the word force there, you can make the other ball go in the corner. Is that what you said?
Yes.
Awesome. Okay, tables, before we move on to another observation, I see your hands. Before we move on to another observation, talk with your partner and think about why. When you give the ball a force, you can make the other ball go in the corner. Why is that happening? Use your science words to help you. What is going on? Talk to your neighbor. What's going on in this? When you make a ball hit another ball, what's happening?
It's like collision. They're like hitting each other, making constant.
Yeah. Transferring energy. Okay.
I was saying that, what was I saying?
So I got a really good observation. So it's where you go ahead and instead of the ball going at it, stopping, and then this ball taking all this energy and shooting it, instead it gives half of its energy. It gives 3/4 of its energy.
Oh. All right, your balls are in the box and we're not bouncing. No, thank you. All right, so I heard some great ideas about why that is happening. And may I say Kenny, is that right? Kenny's words were super cool. He said that part of the energy, he was guessing maybe half, maybe 3/4.
So whenever the harder you hit, the more energy you transfer, and the less energy it actually gets. The other ball gets more. So, and it's really weird when you would think that whenever you would think, so whenever it's a soft hit, it gives half of the energy. But whenever it's a hard hit, it has the same energy as a soft hit because it gives 3/4 of it.
Okay, so he's trying to figure out just how much energy is transferred. But he talked about the energy is transferred from the moving ball to the stationary ball, and the harder the hit, the more energy. Give me a thumbs up if you agree with that statement. Looking around for some thumbs up. Okay. Could you try, for me, number one, it's your turn again. You're going to try a soft and you're going to try a hard, and we're going to see the difference. Again, make sure it stays in the box. A soft and a hard flick. A soft flick and a hard flick. One is stationary in the middle. One is stationary in the middle, and one is moving.
They both move the same speed.
That's it, miss the ball.
What do you think? Sometimes
What happened?
They both move the same speed.
Can we go to the... we go to the twig webs. Do they have their twin books in their desks? I forgot to ask that. Maybe just... we'll work there. Alrighty. 5, 4, 3, 2, 1. So ready right here. Thank you. So ready right there. Thank you. Great. Super. Okay. So we had a soft flick and we had a hard flick. Which one has more energy? Hard or soft?
Hard.
Which one has more energy? Hard or soft?
Hard.
Yes. There's more energy and more, oh my goodness, and more energy is transferred from one ball to another. Yes.
I tried something right this second since I just got back from getting a band-aid, but I kept one ball in the corner and I hit the other one, and the other one hardly moved.
If it's in the corner and it gets hit, it hardly moved. That's an interesting observation. Okay, we have another, right there, thanks. We have another opportunity. We did a hard and a soft. What would happen if we did a fast and a slow? If you haven't had a turn yet, that would probably start with number 2. Number 2. Would you give us a slow and a fast flick? We're going to take just like 30 seconds for this one. Ready? If you, yeah, we might be off on our numbers a little bit. Whose turn do you think it is to go first? Fast and a slow flick. Uh-oh. Keep it in the box.
A little too fast.
A little too fast.
Or too slow.
Have you had a chance? Can we give her a chance in just a second? All right, let's try a fast and a slow flick. Will you guys see what you find out?
Oh God.
Yeah. Okay. We're stopping in 5, 4, a soft and a hard. I'm going to call number 2. Number 2's who I haven't heard from yet. Give me an observation, number 2. Oh, I think I've like heard from every number 2, but okay, here we go.
When I did it fast, the ball actually went out of the box, and it went like it rolled like really fast, and when I did it slow, the ball went slowly and didn't really do that much energy.
Nice. So the amount of energy affected the impact, like how much energy was transferred. That makes sense, doesn't it? If it has a lot of energy, it's more easily able to transfer that energy. Okay, so we tried a setup with 2 ping pong balls. We tried some difference in speed. We tried some difference in the amount of energy. We need to record this in our twig books. Can you please find your twig science book and a pencil and get those out for us? If you press this button here, nope, that one there, I'll know what page number. It looks like we want page 47. Right here is what your twig book pages look like. What's that?
So whenever you go ahead and put so it was an experiment I did. It was like 10 seconds. I found out whenever gravity does it, whenever gravity pushes it down, and then you hit it, it moves farther than if you pushed it down.
Interesting. Gravity is an interesting force. Okay, on page 47, we're going to carry out our investigation. We need to describe our setup a little bit. So can you, in pictures and word labels, draw or write about your setup, which is really a box, a flat surface, and 2 ping pong balls. Take about a minute. Pardon? There are lines here, but you can draw it right there, even though there are lines, if that's okay with you. Let's draw our setup, because what we're going to do is change one variable in our setup, but we've got to record the original here.
I don't understand.
Page 47.
I don't understand what we're supposed to do.
Right here. Could you draw a picture or use words to write what your setup looks like with a box and 2 balls? That's your setup. Yeah, that makes sense now, huh?
Yeah.
Yes.
How do you spell rectangular?
Rectangular. It's going to go ahead and sound it out the best you can. Rectangular. I see some words. I see some labels. Oh, cool. I will model the model. This is a bird's eye view. Several of you had this. That's a chubby finger I got going on there. Guess I need a label for the box. Have you heard about lollipop labels? Draw a circle around it, put the stick there, their arrow. Nicely done. "30 seconds. You don't have to be done, but we'll move on. We're going to think about, if you're ready, you're thinking already about what variable are you going to change. We're going to change one thing in our setup and see what happens. Great job. Looking good. All right, 5, 4, 3, 2, 1, 0. I should have said before we move on, where is the energy transferred and how can we show that on our diagram here? In our setup, where's the energy transferred?
It's transferring to the different ways, and the hands like flickering it, so
So there's some energy here. It's transferred to the first ball, which is then transferred to the second ball. Is there a sound? When you hit those balls, did anyone hear a sound? Will you check that really quick right now? If you have the box on your table, is there a sound at all?
Yeah.
Yes.
There is a sound. That sound is energy. So some of the energy is escaping that second ball by going into the air. So there's some energy there. There's also a little bit of friction. When the ball rolls on that cardboard, some of the energy is transferred because into the actual surface because in the form of friction. So there's a little bit of lost energy there too, right? Like when I roll a ball, if I were to roll a ball, it wouldn't go forever, even if there was nothing blocking it, right? Because the energy is transferred. Okay, you and your table mates are going to choose one variable to change. What thing, I want you to think out loud before we talk. What things could we change in an experiment? Let's start with our picture. Could we change the box? Thumbs up, thumbs down.
Yes.
Yeah, we totally could. We could change the surface. Will you sit down? We could change the surface. Maybe we try some other surface. What other surfaces are available to us? Yes?
There could be like a triangle box or something.
A different shape box. What else?
You could get some cardboard and like make little walls.
Okay, we could change the box. I guess I mean change the box out entirely. If we didn't use a box but we used something else, yeah?
So instead of using the box, which has a medium level of friction, we can use the ground, which makes less friction because of the material it's made out of, and it has like little gaps in between each piece. So it will slow it down more.
Interesting. He has a theory.
But if we use something soft and slippery, like just for example, metal covered with butter and oil,
Wow.
then the ball, then that slippery stone makes more friction, and it will instead of moving on cockpit, it will move. So
So instead of making this,
Okay.
it will make extra friction.
Okay, we could change out the box to use a different shape or the floor or a different kind. There's all kinds of interesting surfaces, right? What else could we change besides the box? What else could we change out to make it a little bit different test? Yes?
Maybe the way we hit the ball.
Ooh, we call that the force, right? We could change the force, the way we hit the ball. What else could we change? Yes?
The amount of gravity it's being forced on, so like a slope.
We could put it on a slope or a ramp. We would get gravity. There's one more thing I really think we could change out, and it would be interesting to me. Remember how we said these balls were light? What could we change?
You could make the balls heavier.
Could make the balls heavier. We have this handy dandy bag of bouncy balls. They're a little heavier. We could try heavier balls. There's actually even bigger heavy balls at the back of your room. What are those for?
We bounce them off.
You bounce them? So we could make heavier, or you do not, or larger balls. Okay, here's what you and your table will write down. You're going to make a new question. You're going to make a new question to test, and that is, we want to change one thing. Can you change two things? Ryan, can you change two things? Nope. Only one thing. Although it would be, you could change out both balls or one ball. You could change out the surface. You could change out the effort. Talk at your table and decide what are you going to change, and then I'll help you write the question.
I would change the ball.
What do you guys want to change out?
Change the ball.
And are you going to change both of them or just one of them?
We could change just one, then we can use like the heavier one as like our pushing ball. So then it will give more energy to the lighter ball.
So your question will be, what will happen if we change one ball for a heavier, bigger ball, or is it just going to be small? What are you going to change out here, ladies?
I would use my table and use the cups to like block the thing.
Like we would
Right
use
there.
the cups for like, so if we clicked it, we could try to like play that game and like look it into the cup.
Me and Emma want to change out one. Like I want to have one a big hefty. You want it like that?
Yeah, we're probably not making a maze for it. I'm not sure I understand, but like it's going to just roll straight, and we want it to roll into the other ball that's stationary or moving.
I would change I'm gonna change the ball with my heavy ball.
Ah, she's liking your idea.
I want to have one ping pong ball and one heavier ball to see how. Which ball do you want?
Okay. All right, we're ready to word our question here. We're going to test it, and then we will see what happens. Okay, so your question, you are going to write this, I wonder what would happen if. Okay, I wonder what would happen if. It's all crooked, I'm sorry about that. It's even crookeder. I wonder what would happen if I used two heavier balls. If I put them on the floor. I wonder what would happen if I used a big ball and a small ball. What's your question? I wonder what would happen if. What would happen if I used two heavier balls? Nice. Once you have your I wonder statement, you're going to make a prediction. You're going to predict what you think will happen. That wonder statement and your prediction is your ticket to new materials. What will happen if you use a heavier ball? What will be the results? What do you think? You're predicting. Then you're going to test it. What will happen if you use heavier balls? What surface?
Desk. The desk.
Desk? Okay. All right. Give me a thumbs up if you have your prediction. What will happen? Just a quick statement about what will happen. Prediction? Okay. Right, your prediction. What think's going to happen? What do you think's going to happen? What do you think's going to happen, Miss Madison?
If we get a heavier ball, then it may get the lighter ball more force.
Can you jot that down really quick? It will give the lighter ball more force. I like that. I think, which one will go faster, do you think?
The ping pong.
The ping pong ball will go faster because of a heavier ball. Okay, I think we're almost ready to test out our final setup. Lots of kids want to try a heavier ball.
Okay.
So can you just give Mrs. Scar a thumbs up if you wanted to try heavier balls? We're going to switch, we'll switch both of them out, I guess. No, it could be one or two.
So I'll give you two and you can decide which way.
Nice. They should be the same size, I hope, all of them, so that should work. If you, these kids are going to change your surface, so are you guys going to try the floor or the desk? Okay. Which can you decide which desk you're going to do? Okay, stand up and let's give that a try. What are you guys going to change again? Are you going for a heavier ball? Okay. All right, I think person number 3, you get to go first. Let's let everybody have a quick try on this. How many flicks? Let's say 3 flicks and we'll let everyone have a turn. Check it out. See what your results are. Okay, you're going for the desk here?
How are we going to keep it?
Good question. It's probably not going to go stay in. It's probably going to
I have an idea.
fall a little.
Put the books around the desk.
Ah, you want to make a little setup here to keep it in? Nice thought.
This is faster. Oh, what the?
Did heavier balls go faster?
And there's less chance of hitting the other ball.
Because, why do you think that is?
Because they're smaller.
They're smaller. There's less chance of hitting the other ball.
That's top skill. Snowman.
All right, what's happening, ladies? When you switched out the ball, what were our results? What happened when you switched out the other ball?
The other ball. I haven't finished.
Okay, let's all watch and we'll try it again. So you've got a stationary, heavier ball.
It propelled this ball further, but I haven't tried.
Oh, this is interesting.
Oh my gosh.
What happens if it hits the heavier ball? I think not right now, but that would be interesting in my science. It's moving around a little, huh? Ooh, did you see that?
Try using that ball to hit that ball.
So what's the difference when you make the heavier ball hit the lighter ball versus the light ball hit the heavy ball?
It goes more farther and more movement.
Which one goes further?
Maybe the light ball.
The heavier ball hitting the light ball, and the light ball goes further? Finish up. If you haven't had a turn to try it, would you make sure you get a turn? You're going to fill in that chart at the bottom, just the top line, telling us what you changed and what was the effect of your change. What I changed and what happened. What I changed and what happened. Did you change the weight of the ball?
You have to touch the ball.
No one has. Except for Robert and Robbie.
How come you're not? Okay, you touched it.
So how is it different on this surface? How is it different on this surface? Perfect. Lots of energy is making the ball move a lot further, isn't it?
The lighter the ball, the farther it goes.
The lighter the ball, the farther it goes. All right, let's take our twig books out and write down what we noticed.
Okay, which one's mine, Robbie?
What I changed and what happened, friends. What I changed and what happened. We're still on page 48.
47.
Oh, I'm sorry. We're still on page 47. Okay. Right here. What I changed and what happened. Okay. Time to write it down. What I changed and what happened. What I changed and what happened.
I need my book back. I need my eraser back.
Let's see if we can get this done in 1 minute. What I changed and what happened. Like I said, I better do mine. What does it say, Mary?
It says that it hit harder.
What? You changed a heavier ball. It hit harder. What was the effect? Did you use 2 heavy balls or a heavy and a light?
A heavy and a light.
So, which one did you flick? The heavy ball or the light ball?
We flipped both. So we did the heavy ball on the light ball, and then we did the light ball on the heavy ball.
And which one made the other ball go further?
Heavier.
The heavier one? Why do you think that is?
Because it's heavier and it has way more energy.
A heavier ball has more energy.
And it transfers it to the light ball. It makes the light ball go flat.
All right, friends, you have done a fantastic job of sticking with it and experimenting with a new variable. I think we have earned we have a formative assessment here on our Twig book. I think I just need from you one more observation about the forces. Oh, let's look at our vocabulary. Energy, collision, transfer, force, unbalanced force, or propulsion. Make a sentence for me in your head with at least one of these words describing something you observed today. Okay, make one sentence in your head using a vocabulary word to describe something you observed today. Think time. 30 seconds of think time. I'm just going to see if I can call on a few hands. I see you. I will probably come your way. Be patient. You have a question? Oh, what's your question? No, you may use more than one. Give me a thumbs up if you're ready to listen to your neighbor. I got a few thumbs up. Thank you. Here we go.
The heavier ball has less energy.
She noticed the heavier ball had less energy. Thumbs up if you noticed something about energy and the weight of the ball. Nice. I'm wondering why that is. Why does she think the heavy ball has less energy? I'm thinking about that. What's your observation?
My observation is that, wait, what? The observation.
What did you observe today?
I observed that the heavier ball gave the lighter ball more force.
The heavier ball gave the lighter ball more force. Lighter ball, more force. What did you notice today?
I noticed that the unbalanced force of a light ball and a heavy ball colliding together affects the energy that's transferred into the other object.
An unbalanced force of a lighter ball and a heavier ball affected how much energy was transferred. Turn to your neighbor and say, wow.
Wow.
Wow. Now turn to your neighbor and in that nice whisper voice, just tell them your observation while I write that one down. So we need to finish up. Tell your neighbor your observation. Go.
My observation was that the ball went faster and by changing place, it goes faster.
Fantastic job. Finish up in 5, 4, 3, 2, 1. Thank you so much. Here's what you need to do. I would like all the materials inside that box lid. I need number 3, or in your case, number 2, to carry it over to this table when you have all the materials inside of it. Finish up your thoughts in your book. Here we go. I've got 2 box lids that can go that way. Bring them over to Mrs. Scar's table there, Rich, please. Okay. When I say energy, you say the capacity to do work. Energy, the capacity to do work.